Hello everyone and welcome to this video. In this video, we're going to talk about representing inequalities graphically. We talked about horizontal and vertical lines. In this video, we're going to talk about diagonal lines and how to describe them or describe the inequalities that represent the
وassignment صح؟
unshaded regions, okay? The unshaded regions. Now, let's take a look at one of the questions here. Example, this one here. Now we have a diagonal line. We need to describe this line by writing the equation of this line and then writing the inequality that describes the unshaded region related to this line, which is this region here. Now, first, let me cover this here. Okay. So first, when we look at the line here, this is the line that we want to describe. First, let me take you back here. So this is the line that we want to describe. First, we write the equation of this line. The line is crossing what? It's crossing the 2 on the y-axis and 4 on the x-axis. Now, to write the equation of any diagonal line, you have to follow the y equals mx plus c steps because you need to describe the equation fully using the gradient and the y-intercept. Now we understand the meaning of y-intercept. The y-intercept is the point where the line crosses the y-axis. And here it's positive 2. So the c is positive 2. And then to describe the gradient, you have to follow the rise over run rule. So gradient will equal rise over run. First, let me write this. So this is positive 2 and this one is rise over run. Now the rise is what here? The rise is the vertical line starting from here, which is 2, and the run is the horizontal line starting from here, which is 4. So rise is 2, run is 4, so it's going to be 2 over 4. So we write y equals 2 over 4, like this, and then next to it we write x, and then plus c, which is 2 plus 2. Now we can see that the line is going down. Line is going down. How do you see this? From when you start from the y or start from the 0 point and you go this way, the right way, it means you can see that the line is going down every time we go to the right part of the x-axis. This means that the gradient is negative. This means that the gradient is negative. So this one is a negative 2 over 4. Now, to simplify this, this means that the y equals negative 2 over 4 is the same as 0.5, which is half x plus 2. So this is the final equation of this line. So focus on the steps. We said that this is the y-intercept, and the y-intercept is the point where the line crosses the y-axis. And after finding the y-intercept, after finding the y-intercept, we want to find the gradient. The gradient is the rise over the run. The rise over the run. The rise is 2. The run is 4. And the line is going down. How do we know it's going down? We start from this point, which is the 0 point, and we go to the right side like this. And we focus what's happening to the line. So the line is going down every time we go to the right side. This means the gradient is negative. Now, we used other methods to find if the gradient is negative or positive. Sorry. The other method is what? The other method is about starting from the y-intercept, going one positive x, like this, and then checking. If the line is under you, it means the gradient is negative. If the line is on top of you, it means that the gradient is positive. So how do you see this? As we said, start from the y-intercept and go to the right side of the graph. Or you can go one positive x and then check if the line is under you, this means that the gradient is negative. If the line is on top of you, this means that the gradient is positive. So the line here is under. This means that the gradient is negative. And to find the gradient, we use the rise over run method, and we find the gradient by that. Now, to describe this part, which is the unshaded region, we notice that this part is under the line. So to describe this part here, we say that this part is smaller than the line itself. This is the line, and this is the part that we are describing. So we're going to say that the y is smaller than this line. So let's write it like this. Y is smaller than, and we said it's smaller because it's under negative 0.5x plus 2. Now let me show you another method to check without saying because it's under or on top, okay? Now, the other method is about taking one of the points. The other method is about taking one of the points in the unshaded region. For example, taking the 0 point here, taking the 0 point. The coordinate of this point is 0 0, like this, 0 0. So the x is 0 and the y is 0. Now we take them and we plot them here. We plot them here. So we're going to say 0. Let me take this down first. I'll check if the answer is right. Now we're going to plot them here, okay? So I'm going to say 0, and I'm looking for a sign here. So I'll write equal and then check, okay? Negative 0.5 multiplied by 0, and then plus 2. Now anything multiplied by 0 is going to be a 0. So 0 will equal 0 plus 2. So 0 will equal 2. Now, which one is smaller here? And by that, I mean, what's the right sign to put here? Very good. I'm going to say 0 is smaller than 2. So I'm going to put this sign, which is the same that I put over here. This means the sign that we're going to use is smaller than. So you can use this method by checking if the points or plotting the points, the x and the y, plugging them in the equation, and then checking the sign or the correct sign that goes with them. Or you can use the method that I told you because the region is under, it means it's smaller. Same idea, and they both will give you the same answer. Now, after we do this, we have to look at the line. If it's a connected line, we put an equal sign under the inequality sign. If it's not a connected line, we don't put an equal sign. So here, this should be an equal sign. And this means that the final answer, this question is y smaller than or equal to negative 0.5x plus 2. And this is how you answer a question like this. So when you find the equation of a diagonal line, first find the y-intercept, write it here, and then find the rise and the run, divide the rise over the run to find the m, which is the gradient. Check if the gradient is positive or negative by going to the positive x. You can go from anywhere, and you'll still see that the line is under. If the line is under you, it means it's negative gradient. If the line is above, it means the gradient is positive. And then to find the inequality sign that you need, if the region is under the line, it's smaller. If the region is on top, it's bigger. Or use this method, the one we're using points, to check if it's smaller than or equal than sign, smaller than or bigger than sign. And then if the line is a connected line, you have to use an equal sign with the inequality sign. Now, let's move on to another question. Here, let's erase this. That's the idea of using diagonal lines and describing the inequality signs using diagonal lines. Let me show you another question that has diagonal lines. And then we're going to talk about plotting or illustrating each inequality on a graph. So we're going to take this question. The rest of the questions, they have the equations written for you. So you have to rearrange them like this, take them to the other side, and then use the inequality sign. Okay. Now, even if you don't rearrange them, the inequality sign will still be the same. For example, here, this region, we want to describe the unshaded region, which is this one under. So if I rearrange this, okay, let me show you. If I rearrange this, I'm going to take the x to this side. So here, let me write it here, to y. As we said, you can rearrange them or leave them as they are, no problem, okay? Equals 4. Now, if I want to rearrange, I'm going to take the x to this side. So I'm going to say 2y equals 4 minus x, okay? And then I want to remove the 2, so it's going to be a y. So y will equal 4. Now, the 2 will be divided by, so it's going to be 4 minus x, sorry, all divided by 2, like this. So all divided by 2. I'll put a line here. Now, the 4 will be divided by 2 and the x will be divided by 2. So focus on this, okay? Even if you leave it like this, it's okay. It's accepted, okay? Because you're only checking or writing the inequality sign here. Now, let's finish this. This means that the y equals 4 over 2, which is 2, and then minus x over 2. X over 2, like this. I don't know if you understand this. Let me write it in a way you can understand it. So it's going to be 4 over 2 and x over 2, like this. Okay, 4 over 2 and x over 2. Let me put the lines here and here. Now, we divided here by 2, so this one was removed. 4 divided 2 is gonna be 2. So the final equation will be like this. Y equals 2 minus x over 2. It's the same as 1 over 2x, which is half of x, which is 0.5x, like this. Okay, same idea. Now, you want to write the equation of this line. We have the equation. Now you want to change this into an inequality sign. Now we notice that the region is under. The region is under the line. Under the line means smaller than. So this sign should be smaller than, like this. Smaller than. And the line is a connected line. This means there is an equal sign under the equation or inequality sign. Now, if you change this from the beginning, no problem. If you put this here, no problem. But make sure that the y is a positive y. But rearranging will make sure that the y is a positive y. And that's the whole idea of this question. Now, same idea with the other one, other part. The region is on top. It means it's bigger than. So you can put a bigger than sign and uh, an equal and an equal sign with it. So you can just put a bigger than like this sign and an equal sign with it. As we said, the equal sign with it is because the line is a connected line, and the bigger than sign because the region is on top, or the unshaded region is on top of the line. Now, let's move on to the diagonal line that needs describing, which is over here. This will be the last question in describing shaded parts or unshaded regions questions, and then we're going to illustrate some of them on the graph. Now, when we look at this shape, we will see that the unshaded region is in the middle here between 1, 2, 3 lines. So we have 3 lines to describe. And describing means write the equation of each line alone and then turn every equation or all the equations into inequalities. First, let's start with the first line, which is the easier one, which is the horizontal line. Now, the horizontal line here is crossing what? It's crossing the y-axis, and it's crossing the y-axis in point 0. This means that the equation will be, very good, y equals 0. So that's the first equation. It's the easy one, y equals 0. Because you'll notice that the y is always 0 here. And then to turn this into an inequality sign, what do we do? Very good. We look at the unshaded region because it's on top of the line. This means the inequality sign should be bigger than. This means the y is bigger than 0. So you write it like this, y bigger than 0, like this. And as we said, because the line is connected, this means there's an equal sign under the inequality sign like this. So the final answer is y is bigger than or equal to 0. And that's the final inequality for the first line. Now let's take a look at the other lines. Let me take this here. Oh, sorry. Let me take it here. Focus on having spaces for all the answers. And when you answer a question, make sure that you order your answer and put everything in order so the teachers who are correcting them don't struggle finding your answers, okay? So we finished the first line, which is here. So the first line is done. Now let's talk about the other lines. This one is done. Let's talk about the other lines. Let's start with this one. This one, same idea. We're going to use y equals mx plus c. We'll notice that the y-intercept is 4 here. The y-intercept is 4. So let's write the equation, which is y equals mx plus c. Now the y-intercept here is what? Very good. It's 4. So the c is 4. And the gradient, very good, rise over run. Focus on this. We know that the gradient, which is m, equals rise over run. Don't forget this. Rise over run. You're going to use this rule in every question that involves gradients of lines, diagonal lines. So the gradient will equal rise over run. Now the rise starts from here, so it's going to be 4. And the run is 3. The run is 3. So it's going to be 4 over 3. Now, when you write the equation, you'll write y equals, like this. As we said, the gradient is 4 over 3. You can write it here. 4 over 3. And as we said, you can make it like this or leave it like this, 4 over 3. Now, we want to know if the gradient is positive or negative. We start from the y-intercept. We go one positive x, and we look at the line. The line is under the arrow that we have. This means that the gradient is negative. So when we write the equation again, we will write it with a negative gradient. So negative 4 over 3, 4 over 3, this. We write x next to it. So negative 4 over 3x. And then the y-intercept is 4, so plus 4. And this is the final equation, this line. So now we have the equation of the line, this. Now we can turn it into an inequality by looking at the region. The region is under the line, as you can see. This means that the region will be smaller than the line. Okay, let's see. Or you can use the point checking part. For example, one of the points is here, the 1 point. This point here is 1. I can use it to check any regions. So this point is 1. I can use it to check both lines, this line and this line. Okay. So for this line, if this one is 1 and this one is 1, so when you multiply 1, when you multiply this is going to be negative 4 over 3, which is 1.3. Yes, 1.3 plus 4. This means the 4 is going to be bigger. This side is going to be bigger. So the y is smaller than this side, or the 1 is smaller than this side. Same idea. I'm going to use it to check this line, okay? So as we said, this point is under this line, so it's smaller than. So the final inequality will be like this. Y is smaller than the negative 4 over 3. I'll write it here. You can write it 1.3, same idea. X plus 4. Okay. So that's the final inequality for this line. So focus on this. I know it's a little bit confusing, but you have to focus on the steps and how to find the inequalities. Now, as we said, the line is connected. A connected line means an equal sign with the inequality sign, like this. So focus on the final steps that you find and make sure that you write the right answer, okay? Now, the last line, which is this one, I'm going to follow the same steps of rise and run and finding the y-intercept. Now, the y-intercept is 4. The gradient is rise over run. The rise is 4. The run is 2. So it's going to be 4 over 2. 4 over 2. And it's going to be 2. So 4 over 2 equals 2. So our gradient is 2. Our gradient here in this line is 2. Same idea, I'm going to check if it's positive or negative. So I'm going to use the arrow that I used here. Let me use it here. Let me remove these two so I can, yes. So the arrow should be going to the positive side from the line itself. When I check, the line is above the arrow. Now this line is below the arrow. And as I said before, it's always a positive step. So start from the y-intercept, take a positive step. Check the line. If the line is under, the gradient is negative. If the line is over, the gradient is positive. For this line, the gradient is negative 4 over 3, as we did here. So the gradient here is negative 4 over 3. But for this line here, the line is above, so the gradient is positive 2. This means that the m is a positive 2. So let's put a line here. So when we write the equation, we will write y equals 2x, as we said, because the gradient is positive, and then the y-intercept, which is 4, so plus 4. And then to check, I'm going to use the same points. So I'm going to put 1 here and 1 here. 1 is equal to 2 times 1, which is 2, plus 4, which is 6. So 1 is smaller than 6. Same idea, because the area or the region is under the line. This means that here we're going to put a smaller than or equal, smaller than sign. So y will be smaller than 2x plus 4. Now, because the line is not connected, we don't put an equal sign over here. So this is the last answer, or the last inequality for the last line. And by that, we finished all of the 3 lines. We found the inequalities of all the 3 lines. We described the unshaded region between the 3 lines. And this is how you answer a question like this. Now, let me check. Okay, now in this question, we're going to illustrate these on a grid. We're going to put them on a grid. For example, here 5, we have x smaller than or equal to negative 5. First, of course, we're going to have a grid ready in the test. So first thing we do, this is the grid مثلا, for example. This is the x-axis, and this is the y-axis. Okay. Now, we need negative 5 on the x-axis. So let's say negative 5 is over here, for example. It doesn't have to be accurate as long as you have the numbers only written. You have to write one number only, the ones you have. You don't have to write all the numbers. Now, you just make a line like this, going through the negative 5. Now, if there's an equal sign, the line is a connected line. And because it's an x, this means that the line is a vertical line, like this. Okay? So now, the region that they want is smaller than negative 5, smaller than negative 5. Now, the region which is smaller than negative 5 is over here. The negative 6, negative 7, negative 8. These are the smaller regions. So don't shade them. Shade the region that you don't want, because this lesson is based on shading the unwanted region, shading the unwanted region, because this region here is bigger than negative 5, and they want the smaller region. So focus on this, okay? So we shade the unwanted part, which is here. We don't have to do a lot of shading, just a little bit to show that we understand the idea, okay? So this answer is for this question. And because there's an equal sign, this means the line is a connected line. Now let's take a look at this. Same idea. Let me put the grid first. Um, yes, grid. Oh, we have time for this. To draw the line, we find the y-intercept and the x-intercept. I know there are a lot of methods to find them, but let me use the method that we know, okay? Or the ones that you like to work with. So first, I want to remove this so I can find the y-intercept and x-intercept first. Okay, so first we rearrange this. So it's going to be like this. I'm going to take the 3x to the other side. So I'm going to say 4y, like this, bigger than, 4y bigger than 12 or minus 3x. So we rearrange them as y equals max plus c plus 12, okay? Now I want to remove the 4, so I'm going to divide by 4 in every part here. 4, 4, 4. Now when you divide by 4, you'll end up with y here, bigger than negative 3 over 4 is negative 0.75 x. And then plus 12 divided 4 is going to be 3. And this is the final inequality or equation for this line. So we divide it by 4 to get rid of the 4. That's the whole idea, okay? Now we end up with the equation or the inequality at the same time. We can read it as an equation and draw the lines together, okay? First, we have to know that in every equation, what do we have? We have the y-intercept, which is the point where the line crosses the y-axis, which is here, the y-intercept. We call it C. And we have the gradient, which is negative 0.75. Now, first thing we do, we have to draw the shape here. Let me remove this so I can work here. Or draw the line. Yes. Let me remove this. So first, let me uh some yes coordinates. Okay. So this is the y-axis. This is the x-axis. I'm just putting some numbers because I need to use them. Let's say this is the 3 here. So as we said, this is the y-intercept. It's crossing the 3 on the y-axis. Now, this means that the point that we start from is the 3, which is here. Let's make it bigger. So that's the first point, which is the y-intercept. Now, we have to go one positive x and then follow the gradient. So let's say this is the one positive x. Let me make it smaller to draw the line. We can find the y-intercept, by the way, which is this one, and we can find the x-intercept, same idea, but this will take more steps of solving. But I can use the gradient to draw the line. So I'm gonna go one positive x and then follow the gradient. So I'm gonna go one positive x like this. Let's say this is one here. Okay. So I went one positive x. Now I want to follow the gradient. The gradient is negative 0.75. Negative 0.75. So I'm gonna start from here. I'm not gonna go a whole one. I'm gonna go 0.75, which is 3/4 of the box. As I said, if you have the grid, you can do it better than what I'm doing here. But if you don't, you can do it something that's almost accurate as this one. So now you found the second point, which is over here. After finding the second point, you just have to connect the points to draw the line. So I'm gonna draw the line over here, starting from this point, going through this point, and like this. So I have the line over here. Now, the region that they want is bigger than this line. The region that they want is bigger than this line. And as we said, bigger than means on top. Bigger than means on top. This means that we shade the region that we don't want, like this. We shade the region that we don't want. And the second thing that we have to focus on is the line connected or not. Now, here we have no equal sign. This means the line is not a connected line. It has to be a dotted line like this. So you have to do it like this, okay? Right. Like this. And this is how you illustrate inequalities on a grid or on a graph. Focus on the steps, on finding equations, focus on the steps of finding the gradients, and focus on the steps of finding if the gradient is positive or negative, because all of these are combined together to help you solve a question like this. And this is how you answer a question like this. So we shaded the part that we don't want because they want the part which is bigger than the line, and the part which is bigger than the line is always on top of the line. Now, let's check if we have something else to explain. We covered horizontal and vertical lines. We covered diagonal lines. We covered illustrating lines on a graph. I think we covered everything in this part of this chapter. And that's the whole idea of this question. Now, if you have a question like this, it's going to be the same, but you will have two parts and the region is in between them. Let me see if I can do this very fast. So here we have the two. This means you'll have this is the y-axis. This means here. Let me do it very fast. So because it's the y-axis, let's cover this. We put the two grids like this, or the y and the x. And because it's the y-axis, let me put this x down because it's a positive y. So we have the 2 and the 5. Let's say the 2 is here and the 5 is here. And the grid is like this. The y is between them. This means the two lines are one on the 5 and one on the 2, like this. One of the lines is a connected line, which is on the two, and the other one is not connected. So it's going to be a dotted line like this. And that's the whole idea of this question. Now, the region that they want is between them. So we have to shade the regions that we don't want, which is outside of the region here. So what's on top and what's on bottom of the 2 and the 5 is going to be shaded because we don't want it. And that's the whole idea of this question. Thank you very much for watching. See you next time.